Namaste and welcome back to the DSA class. My dear friends, today we are going to be solving another recursion based question, and this question is called as print all the permutations of a given string. Now what does the question mean? Let me quickly explain. Assume you have a string called as ABC, right? Now if you ask me what are all the permutations of ABC, I would say there are 6 permutations like this. There are 6 permutations. Now you must write a program which will take a string as input and ultimately is going to print all its permutations like this. Now I want you to understand. Print all permutations, print all subsequences, right? All these kind of print all kind of questions when you hear. By now I want your brain to have wired in such a way that you realize that, hey, yes, this is a recursion based question. So you must now start thinking this way. Alright. Now how can this be recursively solved? First of all, right, let us assume like this ABC, one string is given to me. Now if in case I were to directly ask you, okay, write all the combinations, all the permutations and combinations in which this string can be rearranged, how many of you will be able to confidently write it? Not many. So first of all, don't you think we must understand a certain approach or a process using which one can generate all the permutations? Now first of all, forget about all permutations. How does one calculate how many permutations are there? Well, it's very simple. Listen. There are 3 characters, okay? Now this first slot here, the first slot here, how many combinations can you have if you ask me? I would say you can have 3 combinations here because you can have A, you can have B, you can have C. Would you agree you can have 3 combinations here? So can I say in this particular slot, I have 3 combinations. That's why I'm writing 3. Now, 3 characters you had, right? One of the characters you put here. Now I'm coming to the second box. Now in the second box or cell, if I ask you how many combinations are there, 1 character is gone. Ultimately only 3 characters are there, which means only 2 characters are available to you, which means, would you agree, there are only 2 options here. Now 1 character you placed here, 1 character you placed here. Now coming to the last cell. If I ask you how many combinations or how many possibilities you have there, naturally from 3 characters already you placed 1 here, you placed 1 here, 3 minus 2 is 1, so you have only 1 outcome or 1 possibility, which means the number of options you have here is 1. Multiply all of them, 3 into 2 into 1 is nothing but 6. So if I ask you how many permutations or how many permutations there will be, it is nothing but 3 factorial or 3 into 2 into 1, which is nothing but 6. Hope you're able to think. So this is how you calculate how many permutations are there. Now that you understood, oh, there's going to be 6 permutations. Now the larger question is, how are you going to develop each permutation step by step? That is very simple. Watch it. Let's start, okay, cell by cell, cell by cell. Now let me take the first cell. So see, I'm showing you the first cell. I'm leaving the other cells empty. Now in the first cell, which I'm marking in green color, there are 3 possibilities. We already discussed this 3 possibilities. It can either be A, or it can be B, or it can be C. Would you agree with me? 3 possibilities. Correct. Yes, we understood. Alright, now let's start with this first one. A is fixed, but there are 2 other people here. So now how many outcomes can be there, we will look at it. But now I fixed the first cell. Now I'm fixing the second cell. Now in the second cell, how many options do I have? You already calculated 2 options, which means I'm showing 2 options. I'm marking the second cell in green. First option can be B, second option can be C. Any confusion till here? Great. Now come to this. First one is fixed, second one is fixed, third one. Third one, only how many options do you have? 1, and that is the only character remaining, which means it will be ABC. That is your first permutation. Similarly, second one, A, C. There is only 1 remaining. And what is the remaining character? B. So ACB is your second permutation. I hope you're able to understand. Similarly, come to B, right? So B is fixed. Now we have to talk about the second box. So how many combinations or how many permutations you can have here? 2. So I'm showing 2. I hope you're able to think. And here you can see one can be A, another can be C. Now you're left with only this empty part. So that is only one character. So the remaining character here is C, remaining character here is A. So BAC, BCA. That is your third and fourth permutation. Coming to the C is fixed. Let us talk about the second box. So you know there are two possibilities here. So two possibilities. One can be B, one can be A. Any confusion till here? Next, what is remaining is these two boxes and it's the remaining character. So in this case it will be A, in this case it will be B. So CBA, CAB. 6 possibilities and I am numbering them 1, 2, 3, 4, 5, 6. Any confusion till this point of time? So now did you understand how number 1 to analyze how many permutations and ultimately how to create each and every permutation. I hope till this point of time each and every one of you have been able to understand. However, how are we now going to come up with a recursive solution to this is the bigger question. That let me try to explain to you. Okay. Now listen. Let me start with the given string to me ABC. Now first of all, we are going to convert a string into an array in Java because we want to be able to work with individual characters, and you know directly I will never be able to work with individual characters in Java, but arrays do not have any such limitation. Even in Python, we will be taking the given string and converting it into a list so that you know we can easily work with it, right? Either ways, it's either an array or a list. Now individual characters I can access, right? This much I want you to remember. Now I have A, B, C, my friends. I am putting the index also 0, 1 and 2. Now if you look at this approach, what were we doing? First, we were looking at all the combinations of this first cell. First character, right? And then we were proceeding to the second character, and then finally we were looking at the third character. So that way a larger problem has been broken down into a smaller problem in such a way that first I am calculating all the combinations of the first character or the first cell, then all the combinations of the second, then all the combinations of the third. So we can approach it like cell by cell. Would you agree with me? So watch it all of you. The first thing is I would like to decide on which cell I am working on, right? So let us assume I want to work on the first cell. The first cell is at index 0. So I would like to fix that. Now I am going to fix that and work only on that. So what I will do is to help me keep track of which is the cell I am working on, I will now create one small variable called as Fi. Fi stands for what? Fixed index. Any confusion till here? And the initial value of fixed index is going to be the index of the first character, and you know because of zero based indexing in our programs it is going to be 0 initially. I hope you're able to think. So see, I'm marking that in green color. Now that is fixed. I hope you're able to think. Now what I'm going to do is tell me what are the different possibilities you can have there. You know, because since the length is 3, you have 3 possibilities. First one can be A or can be B or C. So I'm showing you 3 possibilities like this. Any confusion till this point of time? Now the first possibility is nothing but A, B, C. The second possibility, look at it carefully. First character must be B, then obviously it can be A and C. Then look at the third possibility carefully. First character can be C, then it can be B and A. I hope you're able to think. Any confusion till this point of time? So now I want you to observe something carefully. Observe something carefully. Look at the second possibility, right? I have B first, then A. Now there I had ABC. Here I had BAC. Can you tell me what has happened? If you look closely, you will notice that you have swapped the position of B and A. You have swapped the position of B and A. In other words, would you agree that I have swapped the 0th index with the first index? So that is what I am writing here, 0 and 1. See, you have swapped it. Look at this. You have CBA. Ultimately, what have you done? You have swapped A with C. You have swapped A with C. I hope you are able to think. You have swapped the fixed index with the last index, which means 0 and 2 these positions have got swapped. So C and D. There it is, A and C. Hope you're able to think. That way, even this can be represented in terms of swapping, because I have swapped the 0th index with the 0th index. Because if you look at it here, no swapping has happened. If I take the 0th index, swap it with the 0th index, in essence, nothing would have happened. So can I say 0 hyphen 0 like this? So it's one thing I can understand is, to find these three possibilities, I had to swap the fixed index with itself. I had to swap the fixed index with the next element. I had to swap the fixed index with the next element. No more elements are there. If there was one more element, one more branch would have come. No more elements are there. So would you agree, in a way, I will fix an index, start from the fixed index, right? Start from the fixed index, swap, nothing will happen. Move further. With the next element, swap, I will get this. Move further. With the next element, swap, I will get this. So somewhere it tells me that once I decide what is my fixed index, from the fixed index, if I can iterate till the end of the string and keep performing these swap operations, 100% I would have got all three combinations where the first character is what is fixed, and that is what I am changing. So see, A, B, C. I have got it. Any confusion till this point of time? Great. Now let's come back here. Now look at this and understand carefully. First character here we have decided is A. Now the only possibility is for the second character and the third character. But you cannot even start with the third character without first fixing what should be the second character. So now I am talking about fixing the second character, and hence that is in green. I hope you are able to think. Now the character or the index on which you are working on is your fixed index. Previously fixed index was 0, but this time fixed index is going to be 1. Any confusion till this point in time? That is what I am also showing. Fi is 1. Any confusion, guys? Great. Now Fi is 1. Now see here, how many possibilities for the second character? Here already you have seen that the second character has only 2 options. Would you agree with me? Which means 2 branches will come. Let us directly look at the final product. The first product is A is anyways fixed. Second character can be B. If second character is B, this has to be C, right? Second option is A is anyways fixed. Second character can be C. If that is C, this has to be B. Now, how did we do this? Fixed index is 1, right? Start from the fixed index, perform swapping, right? Fixed index with itself, 1 with 1, nothing will happen. So you will get this. Fixed, then move further. Fixed index with the next element, swap it. This is what you will get. Any confusion till this point of time? So did you see how I arrived at this? Now I arrived at this. So see here, first I set the first character, then I set the second character. Now only thing remaining is the third character, so I am marking that. I hope you are able to think. And if you notice, by the time you reach the last character, which means now the index that you are fixing is the last character, which means here Fi is 2, here also Fi is 2. The moment the fixed index becomes the last character, would you agree you have reached a permutation? Both of these are permutations, friends. ABC is also a permutation, ACB is also a permutation, correct. ABC is also a permutation, ACB is also a permutation. Which means, recursively thinking, have I not hit a base condition? I have. And can you guys tell me what can be the base condition here? The base condition is very simple. If in case the fixed index's value is equal to the last index of my array or my list, I have hit my base condition. Would you agree with me? So in a way we have hit a base condition. I am marking it in a different color, and let me also just write my base condition. Can I say like this? If in case the first index value is equal to the length of my array. Length of my array will give me 3, but this is 2, so -1. You know from the length how to get the last index. If this is the case, then I'll hit a base condition. If I hit a base condition, just print it. And what am I printing? I'm printing the array. I have to print the entire array. How are you able to think? So I will just here say print. What to print? AR. How to actually write this in code, we will see. I'm just writing pseudocode. Any confusion till this point of time? Yes, sir. Wonderful. We understood. Next what? Next what means you got both of this. Let's go back. Okay. This branch is over. Now come here. First index is fixed. Now it is time for the second index. So I'm marking the second index, right? So this second index can have only two possibilities. What is the two possibilities? First one is A as it is. Second one is C. How did we get this? Very simple. Here, which index are we fixing? The second character. Second character means 1. So Fi is 1. Fixed index is 1. Start from the fixed index. Swap with itself. Nothing will happen. Move further. Swap the first index with the next character. You will get this. So can I say 1-1, 1-2? Same as that. Any confusion till here? Great, sir. We got till here. What else? What else if you ask me? Now, the fixed index value, obviously, see, you have set the first character, set the second character. Now, the only possibility is for the third character. So, you have to fix this. If you have to fix the third character, obviously, the fixed index value is going to be 2. In this case also, it's going to be 2. 2 is nothing but the last character. Last character means base condition is true. If base condition is true, you found a permutation, print it. So, I will print BAC, I will print BCA. And definitely, those are my next two combinations, BAC and BCA. Any confusion till here, guys? Yes, sir, we understood. What else? What else if you ask me? Now, go back, come here. CBA. Now you have to fix the second character. If you have to fix the second character, I'm marking it in green. Two possibilities only you have. In the two possibilities, fixed index here is 1 because you're fixing the second character. Swap with itself 1-1. You will get CBA. Obviously, this is a base condition, print it, right? Because now in this case, fixed index is going to become 2 because here you are going to now only fix this. And there is only one possibility there. Here also, simple. Fixed index is 1. Next character, move to the next character. Swap it with the fixed index. You will get the CAB. You hit the base here because 1 and 2 if you swap, now you have to only set the last index, so fixed index will become 2. You hit a base condition. If you hit a base condition, all you have to do is print it. So, do you notice you have got 6 bases, 1, 2, 3, 4, 5, 6. And those are nothing but your 6 possibilities. I hope everybody understood whatever I am telling till this point of time. Yes, sir. Clearly we understood. What else? What else if you ask me? Now, the same thing if I have to recursively write. What are you doing? Listen to me carefully. In every call, what am I doing? I am starting from the fixed index. Initially fixed index is 0. It can be 0, it can be 1, it can be 2. But initially it's starting from 0. But what am I doing? Start from the fixed index. In this case it is 0, right? And then I iterate till the end. I iterate till the end of my array and keep swapping. First swap with itself, then swap with the next element, then swap with the last element. So how can you write this as code? Can I write it like this? For I value starting from the fixed index, correct, till the end of the array, which means till the length of the array it has to go, correct. Inside that, what are you doing? You are swapping. What are you swapping? Swapping the fixed index value. So array of I. Swapping the fixed index value with the element, right? Array of I. So array of I, comma, array of Fi. Would you agree with me? What are you swapping? Wherever I is, with the fixed index element, you are swapping. First time I is also 0, fixed index is also 0, array of 0 is also A, array of Fi is also 0, so that is also A. A and A if you swap, it will be in the same position only. Hope you are able to think, right? Swap. Then after swapping, further after swapping, its own permutations can be there. You have fixed one element. After fixing, now the second element you have to fix, which means again the same process has to repeat. Let us assume we call this function as permutation. Would you agree? Recursively again I must call permutation. Pass the array and pass the fixed index value plus 1. I have to increment it by 1. So fi plus 1. And anyways, base condition you have seen. Sir, will this work? Could be a bigger question. It will work, however, it will not work also. Why will it not work, sir? Let me show you. Now, let us just quickly trace the program using the logic that we have just written and see whether it will work, alright? Now, stay with me and listen to me carefully. Initially, the string that is passed to the function called as permutation is this string ABC, right? And also the initial value of first index or the fixed index is going to be 0. Any confusion? Now, what are we going to do? Now, so I'm just zooming it and showing you so that you can see it. I now begins from wherever fi is. What is the value of fi? 0. So, I also begins from 0. Great. Now, what are you going to do? What you are going to do after that is, as you can clearly see here, you are going to swap array of I with array of fi, and again you are going to recursively call the same function, which means, please understand, if I do swapping of array of I and array of fi, the string doesn't get modified because it is the same. A with A means it will be here only. And that is what I am going to send to this, the second call of permutation. Which means, what is going to be the value if you ask me? It is going to be A, B and C only. And of course, fi value is 0. You will add 1 to it and send it. So, fi value is 1. Right? Now, again please understand, the same thing continues. Where you will start a loop where I begins from fi and goes to the end of the array. Right? So, now fi is 1. So, see, I begins from 1. I am showing I here 1. Now what are you going to do? What you are going to do is again swap array of I with array of fi, which means nothing happens. Both are the same. So, B remains as it is. Now recursively you are again going to call. You are again going to call. And hence, what will be the string here if you ask me? It is going to be A, B, C only. fi value will be incremented by 1 and sent. Fi will become 2. Beautiful. Now according to our base case, if the fi value is equal to the last index of the array, you must stop. Yes, I have hit my base case, so I will print this. I will print this. Beautiful. Now, you have printed this. After printing, obviously, here you will have to return it also. I am just showing that. Naturally, you have to return. Now, since you have told return, obviously return must happen. So, I am returning it back. Once I return it, please understand, here the string is the same, right? Now, what is going to happen is, you are within a loop. So, obviously, I will increment. If I increments, I was near 1, now it will become 2. Then again, you have to swap array of I with array of fi. I is 2, fi is 1. If in case I swap, look here. It is the same array. Swapping happens. If swapping happens, naturally this B and C will get swapped like this. And it is the same array which you are going to recursively send, which means you are going to have A, C, B here. And fi value will be incremented and sent, fi will become 2. The moment it hits the base condition, you will print, yes, A, C, B you have got. Then you will tell return. If you tell return, it will return. I agree. But you have returned it. Now when you have returned it, look at this. It is ACB. The array should not have been ACB. Here it should be ACB. But here what it should have been? It should have been ABC. But because you performed swap, ultimately everywhere here you are using the same array. So if you perform swap here, it will reflect everywhere. I want you to understand. So here you have swapped it. But it should not have been ACB. It should be brought back to ABC. Would you agree with me? But that our code has not taken care of. Our code is definitely swapping. After swapping, it is recursively calling. But once it hits the base condition and it returns from this call, and control comes to this line. In this line, you have to ensure that whatever swap operation took place here, that swap operation must be undone. Would you agree? Only then our logic will work. Whatever swapping took place, when you return back, it must be brought back to its original state. How will you bring it back to its original state, sir? Simple. Here I swapped, isn't it? If I again perform the same swap operation, I swapped it. Again, if I swap them, they will come back to their original position. So see, what I will just do here is, I will go and I will tell, hey, please swap. What to swap? Array of I with array of fi, like this I will tell. Any confusion till this point of time? And if in case I do that, look at this. I value is at 2. Our fi is 1. Again, if I swap them, B will come to its original position, C will come to its original position. Would you agree with me? So I will get back the original. And this is what I also wanted to happen. Any confusion till here? And then I will now go back, return, right? Once I return here, obviously this ABC is over. Now here you are within a loop. Please understand, I was at 0. Now I will increment. I will become 1. Any confusion till this place? Now you have to swap. Swap operation happens. If swap operation happens, obviously here this will happen. Hope you are able to think. And that is what recursively you will send. So you will get BAC. You will get BAC, and next what is going to happen is fi value increments, it becomes 1. I hope you are able to think. Then again here, what is fi value? 1. A loop starts here where I value starts from 1. I hope you are able to think. First time you will perform swap operation with 1 and 1, nothing will happen. So nothing will happen, and then you will recursively call it, which means this is also going to be BAC. fi value will be incremented and sent, it will become 2. Any confusion? Yes, you have hit base condition, you will print it. Now you will come back. Once you return, you have to undo the swapping. If you undo the swapping, obviously here what is going to happen is, I am going to, it will ultimately remain the same itself. Any confusion till here? After which in the next line, what am I doing? I value is at 1, it becomes 2. Now I will swap these two. If I swap these two, it is now going to become BCA, like this. That is what is sent. BCA. fi value is incremented, it becomes 2. Base condition, you will print it. Now when you return, after this recursive call, you must undo the swapping, because it must not be BCA here, it must be BAC, and that is what this line will take care of. And hence, if I undo the swapping, clearly one can notice that I will get BAC. Any confusion? After which, obviously, I will return. When I return here, this should not be BAC, it should become ABC. And that is what we will be doing here by undoing the swap. When I undo the swap, this is now going to become ABC. Hope you understood. So it's very important that whatever swap you did, you undo it. Otherwise, it is going to be an issue. And obviously, if you understand these two sides, the other side is easy because it works the same way. Any confusion till this point of time? So this is how recursively one can find all the permutations of a given string. Now the only thing remaining is for us to go and code it. Let's do that. Writing the code is the easy part. My friends, as you can see, I have already taken a string as input from the keyboard using the next method present within the scanner class. Now all we have to do is go here and create a function. So I'll call it as static. It's not going to return anything because it's going to print. So void and I'll call this as permutations. This is going to accept two things. It's not going to accept a string. It's going to accept the character array version of the string. How to convert you will see. Anyways, one character array AR it will accept. And it is also going to accept the fixed index value. So int fi. Cool. Now I'll come inside this and it's very easy. First base condition, if in case the fixed index becomes the last character. So fi is equal to ar dot length minus 1. In which case I will print. So sys out and I will directly print. See, character arrays can be directly printed. No need to use any for loop and all. And then here I will return. Okay. Otherwise, run a for loop. So I'll tell for. What should be there in the for loop? I should begin from wherever fi is, which is whichever the character you're trying to fix. Right? And then you have to keep swapping with every character till the end. So I less than ar dot length. That is, go till the last character, I plus plus. And I will come inside this and all we have to do is swap operation. So we will create a separate function for swapping. For the time being, we'll just call it swap. Now watch it guys. Just to help you understand what we are supposed to do, assume this is the array we have, A, B, C. Okay. I is at the first position, let us assume. Fi value is 0, let us assume. So we want to swap 0 and 1. So for that we have to create a function called a swap. Now to swapping, what and all will we require? Very simple. I obviously require the array because in the array only swapping will have to happen, comma. Next what I will require is the two indexes, right, of where swapping should happen. So I will require I and I will require fi. I will be able to think these three things. If I need, swap should swap the elements present in the array, I to fi, fi to I. How we will do this, we will see. Swapping has happened. Next, again recursively after swapping, now find the permutations because that is what we understood. So I will just again call permutations and I will just pass array and fi. That's it. Okay, but you should not pass fi. Then the next time you are calling, you have to, now you have set one particular index you have fixed. Now the next index you have to fix. So fi plus 1. I hope this one you are able to understand. After which you must know, after finding the permutations, when it comes back and returns, you must undo the swapping. So how do you undo? Just copy that, paste it again. What you swap, you re-swap it, it will come to its original position, right? Great, that's about it. Now the question is the swap. Swap is very simple. Just using a third variable we can swap. So I'll just tell static void swap because it doesn't return anything. It works on the same array. So swap, and in that it will accept in character array. It will accept integer I and integer fi. Yeah. Now it's very simple guys, a simple swapping logic. So what you can do is create a character variable, a temporary variable which can store a character. In that you store whatever is there in AR of I. Right, that's it. Then whatever is there in AR of I, you please assign it to AR of fi. Yeah. Whatever is there in AR of fi, assign it to I. Okay. After which, whatever is there in temp, assign it to AR of I. That's it. Yeah. Whatever is there in temp, assign it to AR of fi. That's it. Any confusion till here? So this is simple swap operation. Take whatever is there in I, store it in a temporary variable. Whatever is there in fi, give it to I. Whatever is there in this temporary variable, give it to fi. So I and fi would have got swapped. Simple as that. Great. Now let us see whether it works. So I'll just come down, and here the only question is we have a string, but we need to pass a character array, isn't it? So I'll just tell like this. I'll call permutations, and upon calling permutations, what I'm going to do now is I will convert the string into a character array. How? Yes dot to character array. That's it. That's it. And then I'm going to go there and I'm going to make initial value of fi is 0. That's what you have to pass because it's always the first index that you will be fixing, right? Wonderful. Let's just execute and check this out. So if I execute it, as you can notice, this is how you will get the output. So I'll get capital A, capital B, capital C. If I press enter, then ABC, ACB, AC, BCA, CBA, CAB. Perfectly it works, 6 combinations. It will work for every single input. I hope each and every one of you understood the logic to the program. But please don't stop here. Soon after this video, make sure you go and you're typing and practicing and also solving the assignment questions, which is the most important thing to build up your knowledge. Anyways, let's catch up in the next video.